Hi everyone. So here I have written down some U-substitution integral examples. I'm going to show you like the shortcut way of doing these. I'm not going to write out all the steps for what U equals and what du equals and then do the actual substituting and all of that. I'm going to show you a shorter method that will work. So the first thing with any integral is to look and see if there's an inside function. So in number 1a, if I look closely, I can see that 3x plus 6 is an inside function because it's raised to the 7th power on the outside. So the very first thing is to ask yourself, what is the derivative of the inside function? Well, for 3x plus 6, now you don't have to write down these steps, but for 3x plus 6, it's 3. Now the second thing is to look and see if that 3 is sitting in the problem. And it is. It's right here. So as long as it's sitting there, then basically you get to ignore it and then just take the antiderivative of the outside parenthesis of the outside function. So all I'm going to do, I'm going to ignore the 3 and I'm going to rewrite the antiderivative, which would be 3x plus 6, add 1 to the power, so that becomes an 8, and then divide by the new power, which is 8, and then make sure you do plus c. Alright, that would be the equivalent of a simple integral, like if I had the integral of x to the 7th, let's say. Now in this very basic integral, there is no inside function, so I just do kind of like the reverse of the power rule. So I would get x to the 8th, just add 1 to the power, and then divide by the new power, and plus c. So if I had a simple integral, that's what the answer would be, is x to the 8th over 8. So it's the same thing with our more complicated looking problem, but it's just the inside function to the 8th over 8. So the inside function stays there in the answer. So now let's look how this would work for letter B. The inside function of this one is 5x plus 4. So its derivative, let's just jot it to the side, 5x plus 4, its derivative is 5. Okay, now the 5 is not sitting anywhere in the integral, so let me put it there. All right, the 5 is right there. Now I can balance that out by putting a 1/5 on the outside, because that would actually cancel the 5 and it wouldn't change the problem. So if your derivative is just a constant and it's missing, no problem. Just put it right in to the integral. So now what we get to do is ignore that 5 and do the 5x plus 4, raise it to 1 power higher, the 11th, divide by that new power, 11, and then add c. Now the only other thing is this 1/5 that was in front, that'll still be there. So it'll be 1/5 times that. So let's just write it a little more simplified. We'll have 5x plus 4 to the 11th all over 55 plus c. Alright, so if your inside derivative is a constant and it's not sitting in the integral, that's fine. You just stick it in. It becomes harder if the inside derivative is not just a constant. We'll get to that in a second. So now in letter C, the inside derivative, the inside function is 8x plus 1. So if I just jot down 8x plus 1 to the side here, its derivative is 8. And I notice there's no 8 sitting in the problem, so I need to put an 8 in there. And on the outside, I put a 1/8 to balance it out. This 8 that's inside, I now get to ignore. And I get to take the antiderivative of the outer function, which this time is cosine. Well, the antiderivative of cosine is sine. So I have sine, and then I just rewrite 8x plus 1. And then there's a plus c. But the 1/8 that was in front is still in front of the answer. So we get this. Now also notice, I'll highlight the inside functions. They never change from the integral to the answer. So see, like 3x plus 6 was the same thing in both the integral and in the answer. Same with the 5x plus 4, and same with the one we just did, the 8x plus 1. So the inside functions never change. You're really just doing the antiderivative of the outside. And now let's go over to number 2. These are a little bit harder because the inside derivatives aren't just constants. They're going to have an x involved. So in 2a, the inside function is x squared plus 5. So if I jot to the side, x squared plus 5, its derivative is 2x. Now we're in luck because there is a 2x sitting right there in the integral. So ignore it and then take the antiderivative of the outer function. So x squared plus 5 becomes raised to the 7th, and then divide by 7, and then just add c, and that's your answer. All right, now let's do one that's slightly harder. If you look for an inside function in part B, you can see one right here. There's an x to the 4th that's inside of the cosine. So x to the 4th, its derivative is 4x cubed. Now, there is an x cubed over here, which is good, but there was not a 4. So I'm going to just stick a 4 in, and I'm going to counteract that by putting a 1/4 on the outside. So now what happens is I get to just completely ignore the 4x cubed, and I get to take the antiderivative of the outer function, which in this case is cosine. So the antiderivative of cosine is sine, and recopy the inside function, so sine of x to the 4th. I put the 1/4 in front of it that I included into the problem, and then plus c. And that's that answer. All right, and then in this last one, we have an e in our problem. So the exponent of the e is acting like an inside function. So the sine of x is the inside. So if I just jot down over here, the derivative of sine is cosine. Now that's great because there's a cosine sitting right here. So we get to ignore that, and we get to take the antiderivative of just the outer e. Now e is nice because the antiderivative is just the same e again. So it's just e to the sine of x, and then plus c. And that would be that answer. All right, so let's just jot down at the top here. Number 1, look for an inside function. There won't always be one, but for right now there will be because you're learning about the U-substitution method. So look for an inside function. Number 2, jot down its derivative. Number 3, look for that, or look for that in your integral. And you know, for right now, it'll be sitting there somewhere, except for maybe a constant. So that's all right if there's a constant missing. I showed you a few examples where you just put the constant that you need into the integral, and then you counteract it with the, like when you put in a 4, you put a 1/4 on the outside. So look for that in your integral, and then if it's missing a constant, write that. I'm running out of room. I'll put it down here. Write that into your integral and multiply by the reciprocal. Okay, and then once it's all set up and ready to go, you take the derivative of the outer function and you just simply rewrite the inside function as is. Let's look at page 2 here. I've got just a couple more set up. The ones in number 3, you probably are noticing that on the bottom we have 2x squared plus 5, and if you think about its derivative, 2x squared plus 5, its derivative is 4x, and that's what's sitting on top. Now that's no coincidence. When you have this type of situation where you have like du over u, so derivative of something over the original, that's really common because that answer is going to be the natural log of the bottom. So this will be the answer because that's the antiderivative of du over u. So this is what the answer will look like. So be on the lookout for this happening. So that's exactly what we have in part A here. So if I just write ln of 2x squared plus 5 plus c, that's the answer. All right, now look at part B. The bottom has the higher powers, so if I test this out, 6x squared plus 8x, if I take that derivative of that, I get 12x plus 8, and if you notice, if I divide 12x plus 8 by 4, if I just reduce it basically, I do get 3x plus 2, which is what's sitting on the top of my integral. So we basically have du over u happening in part B, but I need to multiply the top by 4 so that it would exactly equal 12x plus 8. And then if I do that, I have to put the 1/4 on the outside. So here, let me just rewrite the integral. I have 12x plus 8 on top over 6x squared plus 8x. So I really do have du over u happening. So I know from before that that means the answer is the ln of the bottom. So it's the ln of 6x squared plus 8x. And put the 1/4 back in front of your answer and be sure to add c. Now, I just wrote down these last two. I don't want you to confuse the ones in number 4 with the ln, because yes, the bottom has an inside function, which is 2x squared plus 5, and its derivative is 4x. But the bottom is also to the 9th power. So well, you can't do an ln for this kind, since the bottom is to the 9th power. What you really have to do is rewrite it like this. Change it to the -9th, which is the same thing. And then we have the inside function right there. Its derivative we said was 4x, so like the front page, we get to ignore that, the first problems I did. And then the answer will be the inside function 2x squared plus 5. We just add 1 to the power, so that makes it to the -8 over the new power plus c. And that's how you do that kind. Okay, so instead of doing one more problem, let's just summarize what we did on this second page. So basically, if you have the derivative of something on the top over the original function, and that's an integral, then the answer will be the ln of the bottom. So be on the lookout for those types. But if you have the integral of a derivative on top over the original function on the bottom with a power, just remember that's not going to be the ln of the bottom. That is going to be a problem like this instead, which is actually more similar to the problems on the first page. And that's it.